Did you guys see that grandma? She was crazy. Oh my goodness. Really, really scary. Speaking of things that are scary, I want to talk to you about this next topic. Oof. We have had this type of problem on multiple FSAs, and it has been a real doozy. It has been really, really challenging for us, more challenging and more scary than the monsters that are in your closet. So let's really make sure we focus on this next video. Number 2, match situations to expressions. Okay, the biggest thing that we need to remember about matching situations to expressions is the difference between a coefficient and a constant. A coefficient and a constant. A coefficient and a constant. So, a coefficient is something that we're multiplying by. So in this expression, 25 plus x, the coefficient is going to be 25. So that means that we're timesing by 25. So in all of our problems when we're trying to match, we need to make sure that we're going to be timesing by 25. Now we also have a constant. Remember, a constant's kind of sad. He's just there all by himself, and he's just something that we're adding. So in this situation, the 10 is the constant. So remember, a coefficient is what we're multiplying by. A constant is just what we're adding to a problem. So if it said 25 groups, that would be a coefficient because we're timesing by 25. If it just said, oh, and then he found 10 more, 10 just means we're adding 10 more. So it's something that's by itself, it's alone, that would be a constant. Okay, let's check this out. Consider the expression below. 25x, coefficient, plus 10, constant. Excuse me, got a bad fur ball in there. Decide which of the situations described below can be represented by this expression. Select all that apply. Remember that little tricky word there, all? That means that there could be more than one answer. So let's check it out. A. Martinez has 10 bags. They each have X amount of buttons in them. So I can imagine he's got these 10 bags, X buttons, X buttons, X buttons, X buttons, X buttons. Kind of reminds me of the last problem, not that I would remember because the last problem was a grandma and I'm just a monster. I'm not the same person, don't think that. In the last problem, it was like 6 groups, which is why we had those 6 bags for the lunch. So here this is like saying we have 1 bag, 2 bags, 3 bags, 4 bags, 5 bags, ... You get the idea. And they each are going to have X in them. Then it says he also has 25 more in a separate box. So when I think about that, I think that, well, the 10 is timesing by the X because the X is in each of those 10. So this one is telling me 10X. Then it's saying I have 25 in a separate box. Those are just alone. That's like a constant. So that's going to be adding 25. If I look at this one, this is not the same as this. The constants and the coefficients have been switched. So A does not work. 10 is the coefficient here because 10 times X, that's how many buttons are in every single bag. Just like in the last problem, there was 2 sandwiches in our 6 bags for Mama Jones's children. Now let's check out the next one. It's going to be really hard for me to draw, so I'm sorry if it looks weird because I don't have fingers. Sonia has a coin collection. She has 10 pennies and X amount of quarters. How many cents does she have? Well, hopefully she has some sense to figure out all her cents. Now let's check this out. She has 10 pennies. Those are just kind of by themselves. Pennies are sad. They're not worth that much money. That's just going to be just plus a regular 10. It's just a constant. Then she's got X amount of quarters. So when I think about quarters and I think about cents, because it says how many cents she has, I know that I have 10 because those are my 10 pennies, each worth 1. And then it's going to be worth 25 because that's how much each quarter is worth, X. If she has 1 quarter, 25 times 1 is 25. If she's got 3 quarters, 3 times 25 is 75. So this is what our expression should look like. Now, if I look at my expression at the top, 25x plus 10, even though this is switched, that's okay. In addition, order doesn't matter. So this is one of the correct answers. Select all that apply. Let's make sure we got it. She's got this coin collection, 10 pennies. That's just by itself. It's a constant. We're just adding 10. Then she's got X amount of quarters, so we're going to do 25 times each number she has to figure out how many total quarters, how many total cents we have. Yay. Uno más, uno más. Let's check out the last one. Mauricio has $10 in account. Rolling. He earns $25 per week for babysitting his siblings. What a nice kid. How much money would Mauricio have after X weeks? So he's got this 10 bucks. That 10 bucks is just standing alone. It's like a constant. So that 10 bucks is just there. Then every single week, he starts making that bank, make that money roll. He gets 25, 25, 25, 25, 25 every single week. That to me sounds like a coefficient because every week it's going to be 25. So I'm going to make sure that I write, he starts with 10, and then I'm adding 25x. If I look at this carefully, it actually is the same as B, which is the same as our original expression. So when I select all that apply, the correct answers are B and C. Right now, scholars, you have 2 more problems. Please take your time. Do not scare the monster because these problems are challenging. You really got to think about constants just by themselves versus coefficients, what we're timing by. You got this. Don't be afraid. Don't be afraid. I want to hear you laughing because actually, spoiler alert, in Monsters, Inc., laughing is actually better than being afraid. So go have fun, kiddos. Rawr.